So from the comments I've got on my channel, I'm assuming that a lot of you guys are kind of burned out on AI content. So I'm going to try to do more high-level teaching and diagramming content so you guys can actually learn something, if that's even something that you guys are interested in. I guess we'll see the analytics after making this. So I wanted to talk about load balancers because I do think when you build out a system, understanding how a load balancer works and what it does is important. So again, you probably already know this if you're senior engineer, mid-level, but maybe you're getting into the industry or you're a junior. How do you have your service get traffic to it? And as you get more and more traffic, how do you actually support a bunch of requests per second? So I'm going to walk you through a really simple example, and then we're going to kind of expand out to handling more traffic. So the simplest example is you have a box here. I'll just call this your VM. And you basically have a service running on this VM. So I put like a little circle here for service. And this could be your little Node API or Rust or Go API, right? And the idea is that when you spin up this VM, you're going to get an IP address. So I'll just go ahead and put some random loopback address so that it doesn't think that I'm doxing anybody when YouTube algorithm reads through this. But imagine this is your IP address. And technically, you can actually just go to your browser and you can type in whatever that IP address is. You'll get a public IP address. And you might also get an internal private IP address. For example, if you're hosting on AWS, inside of their VPC, they're going to give you an internal address, which allows services inside that same VPC to connect to each other and not go over the public internet. But anyway, so if you have a VM here and you have your Node application running, typically your users, when they load up their browser, if they type in that IP address, they will get a response back. And then that should potentially just show back, you know, whatever your Node API is hosting. Maybe it's static files. Maybe you have a Django app in here. Okay. Now, typically in your browser, if you just type in that IP address and you don't put a port, it's going to try to hit it over port 80. But if you use HTTPS, it's going to hit it over port 443. Okay. So whatever you run in the service has to either be on port 80 or port 443, but you won't be able to have HTTPS unless you have a real domain. So how do you actually set up a domain for this VM? That's where you have cloud providers like Cloudflare. I think AWS allows you to buy domains potentially now. I'm not really sure. Or like Namecheap is also another place. So sitting in front of your VM, you might have, for example, I'll just say Cloudflare. And this is where you can go and you can buy a domain. All right. So you buy a domain, and instead of the user hitting your IP address, because obviously that's a really bad user experience, you'd actually go into Cloudflare and you say, hey, I bought a domain called example.com and I need you to point that to my public IP address over here. So to kind of show that, let's go to Cloudflare. When you buy a domain in Cloudflare, you can set up different types of records. So this is DNS. This is a whole nother discussion or topic we could make a video about. But basically, when you have your VM over here with your IP address, your public IP address, what you do is you come in here and add a record. And if it's pointing to an IP address, you want to use an A record, right? So put that same domain, and then you put in whatever subdomain that you want, or you can do @ for root. And when I click save, that is going to create that record so that when users actually try to go to example.com, it's going to traffic through Cloudflare and take us straight to our service that's running on that VM. Now, out of the box, this won't just work unless you were to, in Cloudflare, turn on like proxy routing or something. For the most part, you typically have to have a service living inside this box that can do the SSL certifications, right? So this is often when I bring in another service called Caddy, which is a type of load balancer. So I'm gonna go ahead and just put, I don't know if I have an icon for Caddy. I don't. So let's just do this. We'll say Caddy, and this is a load balancer that you can put in front of your services. And technically this can just live in the same box as well, right? So you have a VM, and now instead of just having a Node API, you have a Caddy service which automatically does the SSL certificates, and you can point that load balancer to your service. Okay. Now, to kind of show you an example of this, because right now we're starting to get more into like the abstract of how this all works. How Caddy is configured is you basically just have to install Caddy. It's like an open source library you can install, and then you just have a file. Right? In this file, you can define a domain and you say, I want to do a reverse proxy to whatever the internal IP address is of that. Okay. So basically you'll have like a file, and inside that file, you might have something like this, like a configuration or JSON file. And it basically is going to tell Caddy, hey, when I get a request from example.com, I want you to route the traffic to my node API over here. Okay. And the reason we're doing this is because you can actually have, 10, 20 different domains all pointing to the same VM, but you need to figure out how to route that traffic based on the domain to the internal IP address of the service. Okay. So that's kind of how a load balancer works on a single VM with your certificates all set up. Now there's more stuff that's going on in the hood, like Caddy will talk to a service called Let's Encrypt. It's basically a free way to make SSL certificates so that you can have HTTPS. And then there's like a challenge that goes back and forth, so it actually verifies that you owned the domain. I'm not going to dive into that. I don't think it's kind of relevant to the talk about load balancers. But at some point you might decide, you know what? I need to have multiple services so I can support more traffic, because right now you have a single point of failure. You have a VM. If someone were to DDoS this or something goes wrong in this machine, your service is going to go offline, and now your load balancer is not going to work because all your traffic is going to a broken machine, right? So how do you make a application that can handle more traffic and is resilient if this service were to go online? And also even just doing an upgrade. How do you update this to version 2? If it's on version 1, you need to get the version 2. Typically, you have to take it offline for a little bit and then bring it back online for the next version. So these are good examples of why we have a load balancer, because it allows us to do rolling deployments. You could do blue-green deployments. You can switch traffic over as you upgrade or as you triage what happened with that service. Okay, so let's kind of back off and do a more advanced scenario. So we have the load balancer, and we want to actually move that to a separate VM. So typically you probably want to have at least 2 different machines so that if something were to go wrong on the actual service running, your VM or your load balancer is still working, right? So you probably want to put Caddy on its own machine here. And that could point to, if it's on the same VPS or VPC, I mean, that can still point to some internal IP address. So if you imagine this is actually like, I don't know, I'll just change this to that. Here's the VM's IP address, and you're going to point to a particular port on that. So let's just say 8080. This could be running on port 8080 over here. And then traffic would still go through Caddy to get to that VM, okay? Now, what are the benefits of doing this? Again, if the service were to go offline, you still have the load balancer working. So if you were to have different services inside that box or inside different boxes, it would still work. All right, so let's dive into some of the scenarios I talked about. The first one is, how do you support more traffic, right? Well, obviously, if you have a load balancer, you can have more machines running on different VMs. So you might want to have another one running over here, and this could be on a different port. It could be port 2 or something like that, and you'll have the same node API running. In the load balancer, you can actually configure it to do like a round robin routing type of approach. There's other types of routing approaches. Maybe we can make another video about that. But the idea now is that you'd actually have an example configuration file where you would specify the 2 different IP addresses. I think you can basically just do this. I'd have to go and read the actual Caddy documentation, but this is just an example, right? You then put another record inside a Caddy so that Caddy knows when I get a request to example.com, I need to route to either this box or I need to route to this box, okay? Now, the benefit of this is if you get a bunch of traffic, it's not all going to hit the same box, right? It's going to be distributed between the first VM and the second VM so that the CPU and the traffic and the memory usage of the machine can stay lower, and you can potentially support more requests per second, right? And you can fan this out. You can keep making more VMs to support whatever traffic needs that you want. Maybe you have, an old application that can't really handle as many requests per second, like you are using Node instead of using Rust or something. There are reasons why you want to have a load balancer kind of handle this stuff. Now, another good scenario as to why you want a load balancer is, let's say you want to upgrade Node to version 3. Well, how would you do that? Typically, you'd want to deploy a new version of your application, okay? You want to have it run on a potential different port, okay? So I'll just say 8081. And as it's spinning up, at some point it's going to finish. You want to check to see, hey, is this thing healthy? So most of these services, when you build out these services, you want a health check endpoint, which the load balancer can verify first. Okay, we're going to say, hey, is this service healthy? Is it returning a 200 response when I hit the health check endpoint? And if it is, what you can do is have the configuration automatically switch to, instead of pointing to 8080, you can just point it to 8081. so that all new traffic will then start going to this new node. And then there's something called draining, so that eventually this service, maybe you have like a drain timeout after 60 seconds or 2 minutes. You just assume that all the traffic has been routed to the new node, and you can just go ahead and take the old node offline. This one's no longer to be operational, and this one can be operational as well. Okay, and you kind of have to do the same thing if you have a different VM over here. You have to kind of go through your nodes one by one. There's different strategies to do 2 at a time or whatnot. But eventually everything will be on V2, or sorry, V3, just doing that same approach, right? Now, obviously, if you're using Kubernetes or some other more powerful tool, it does all this stuff for you. Even like a Docker Swarm, I believe, will do this type of rolling release. This is called a rolling release, where you can like get new versions out there so that people can start using it without having downtime. Okay, so 2 good scenarios of why we have load balancers, right? It allows you to handle more traffic. It allows you to continuously handle traffic while you're changing stuff on the back end. It also allows you to shift stuff around. Like, let's say you decide, you know what, this box is just completely broken. We need to get all the users off this box. So again, all you have to do is just, you could spin up like a new VM over here, create a service, add a record, so that all your traffic for new requests could potentially go to this new box. And then you just basically go here and you delete a record, right? You would have 3 records at some point. So I'll just say like 1, 2, 3. Let me zoom in because it's kind of hard to see. Okay, so you have box number 1, number 2, number 3, and let's say you want to decommission this old box because, I don't know, maybe you spun it up and you ordered a dedicated machine that doesn't have enough memory or RAM, and so you want to buy a bigger one that has more power. Well, you have to get users off of this. You don't want traffic going to this old VM, so you have to basically spin up a new one, get your services running on it, add a new record in here, and then somehow you need to delete this record so that your load balancer will no longer send traffic to the old one. And then at some point, this whole thing is basically not being used. There's no traffic going to it anymore. And then you have all the new traffic going to your new service over here. And then, of course, you have some system that can automatically detect if there's no more traffic, then just go ahead and delete the whole VM or the whole EC2 instance or something, right? So this is great, but we still have an issue. This is a single point of failure. We have one Caddy instance that's trying to serve all this traffic. How do we actually make sure that we can handle all of the traffic for your millions of users that you may have, right? You still have to update Caddy. At some point, there's going to be new versions of Caddy. You need to update these. So how do you achieve that? Well, again, you'd have to do some type of similar approach where you need to actually do some type of horizontal scaling of your load balancer. Instead of having your load balancer live on one VM, you could have it live on a cluster. Okay, you can have it, different layer. This is like your load balancing layer. Sometimes you call it an edge, where you actually have many different load balancers. They're all basically configured the same way to point to these machines, right? And instead of having your DNS provider point to just one box, inside of your DNS provider, you'd have a DNS record that points your domain to all 3 of the load balancers. So then when you try to actually go to example.com, if you were to do like an NS lookup in your terminal or a dig, it's going to return 3 separate records for you. And your clients can then decide, okay, I'm going to pick one to actually hit. And then once you hit that one, it'll then traffic to the right VM. I know this graph is looking kind of crazy, a bunch of arrows and stuff. So, but this is the overall idea. Like, in order to handle scale and also in order to have a reliable application, you have to have multiple horizontal layers, right? You have to have multiple VMs all running duplicates of what you want. And then you have to have some type of complex logic in place so you can update these and upgrade these and not have downtime as they're going to your services. Now, luckily, there's been a bunch of really genius engineers who have built systems that automatically do all this for you, like Kubernetes, or if you just use like a cloud provider, they basically do this stuff for you. But under the hood, this is kind of how it all works so that you can actually handle all the load that's going to your different machines. Yeah, that's about it. Let me know if you guys like this approach to teaching. I'm going to try to do more high-level diagrams to try to teach infrastructure stuff, because I do think AI is making the implementation details of things kind of slowly go away and be less important. But understanding at a high level how software works, how web applications work, how these systems are all hooked together is extremely important, because when you have the correct terminology and you understand how this works, you can prompt AI much better to get much more accurate results at the end of the day. Okay. So yeah, let me know how this went. I'll make more of these. If you guys enjoyed it, have a good day and happy coding.